Do you want me to repeat any parts of this? Whatever I covered so far, if you want me to repeat again, from this point, the lecture will be recorded. Okay. Okay. I forgot to press the record button, but again, we go back here. Let's just give a brief of what we covered from the beginning. So these are some basic checklists, and what I wanted to discuss is two control steps for time and cost to monitor the progress of any project. Okay, so time and cost. For time, we have the tracking Gantt chart, control chart, and the milestone schedule. For the cost performance, we have a number of terms that we have to look into. 3 different tools for monitoring time, tracking from the baseline Gantt chart and tracking Gantt by comparing after every time step, what is the status of each activity and how this is tracking with the baseline Gantt chart. Second one is a control chart, a very simple illustration of how whether the progress is behind or above the ahead of the schedule. And third is the project milestone schedule. Again, a set of checklists here. Then we started discussing about earned value, what is earned value, and the set of terms that we must look into for earned value techniques. These are the definitions or the glossary of terms that we must understand for cost performance of any project. All right. So each of these are will be all of these provide invaluable information to monitor the progress of the project. And although these are dollar values or in terms of total cost of the project, if we can link that to the planned value or the baseline budget, it can also give us the information about time. All right, so this is where we are in this. So after defining all the terms that we need, then if we go, if you look into the graph here, cost schedule graph. So we are, so this is the PV or the planned value baseline. All right, project duration, schedule, and let's say this is 46 days from starting from the beginning. All right, what is the beginning date? This is the early start of the very first activity in the project network diagram. So the PV or the planned value of the baseline, it shows the budgeted cost at completion here, which is in terms of the 100,000. So this is $400,000 or 400K. All right. This comes from the planning stage. We have this number already. So we know that the project must finish within $400,000 and 46 days. This is the limit. In terms of time and money, this is our limit. All right. Now the project started. This is the earliest start time of activity 1. All right. Starting from day 1, the project started, and we have completed day 10, day 20. Say, for example, now finishing off day 25. We are here. Okay. So now let's look into the other number. So after finishing day 25, we are now here. Okay. In terms of the total number, so this graph here shows the earned value. All right. So it shows that 50%. Okay. 50% of the project is how much completed. So if you look at the all those graphs here, so this is earned value. The very top one is the actual cost. Okay, this is actual cost here, 85%. All right, actual cost. This is planned value. We plan for at the end of day 25. The plan was to complete 75% of the project. Budgeted cost $300,000 at the end of day 25 here. Okay. So how much is completed? How much is completed at the end of 25? 50%. Okay. So from the total budget, so if you complete it, we know the total budget is $400,000, right? So how much is the earned value of the work completed so far? 50% completed times initial budget was 400K. So that should give us 200K or 200 if we don't use the 1,000. So this is the earned value of the work completed so far after the finishing of day 25. Plan was to finish 75%, but we finished 50%, which has the earned value of 200,000, right? But in actual cost, the actual cost to complete that, this is the actual cost here, the deep blue color, solid blue color. Actual cost to complete was 340. So if we take the percentage, all right, so that is almost 85% of the budget. So the actual cost to complete was more than the planned value, more than the planned value and the earned value. $340, yes. So the actual cost, the actual cost is 340, all right, which is more than the planned value 300 and earned value 200. So what we did is we actually earned only $200 value of work by spending $340. 25% more than planned. So the plan was, the planned value was $300. So at the end of day 25, we should spend $300 and complete 75% of the project. Okay. Right now, if you look at the earned value, but the actual cost after day 25 is 340, which is more than earned value. So what we need to look into, actual cost, AC, and percent complete. After each time period, what is the actual cost and what is the percent complete? This number will help us in identifying the earned value, planned value, and all the variances. All right, I repeat again, here at the end of day, say for example, day 25, the plan was to complete 75% at a cost of $300. Now, I say actual cost and percent complete. These are the numbers that we get after each activity is completed from the project team, from the team of people that are involved in that activity that can give us the total number. All right, this is done. And or this percent of these activities is now complete, and we spend the actual cost. This is the dollar value. So at the end of day 25, the actual cost of actual cost so far is 340, right? Which is not favorable because this is beyond the planned value. Okay, so this is the actual cost. Now that at the end of we are asking the progress report from the project team for each set of activity, and the actual cost that we got is above the planned value. And now if we ask, and the second question, what is the percent complete? How much work? So if we have if we have 10 milestone or 10 specific tasks for any work packages, say for example 5 is done, 5 still remaining, so we can have a tentative percent complete of that work package, which is, so if it is 50%, all right, this is percentage of work complete. This is the actual cost. Okay, so 50% is actually the, if it is 50%, then what is the earned value? Earned value, EV, is simple, 50% multiplied by the total budget. So this is BAC for budgeted cost at completion, 400, right? We completed 50%, right? That gives the earned value. That means we earned $200 value of work so far. That's right. So earned value is $200 at the end of day 25. Alrighty. Then is it good or bad? As you can see, now that we know this is significantly less than the actual cost, because they actually we spent 340, but we earned a value of only 200, right? So that means we need to refine the budget. This is an unfavorable situation or bad situation to be in. What can you do now? So if we, then what are the variances? So now let's look into the cost variance and the schedule variance. Cost variance is the difference between the actual cost and the earned value here. So how much is the cost variance? 340 minus 200, 140. So $140 is the cost variance for this project. What is the schedule variance? 100. Okay, is it minus or plus? This is minus. Minus 140 minus 100. Okay, so both are minus because earned value minus planned value and earned value minus actual cost gives us the cost variance and the schedule variance. All right, so now here we can see we are in a negative, both are negative variance. The cost variance and the schedule variance both are negative. So we need to redefine the budget here at this point. So there is no way that we can finish it with the remaining 60K, with the remaining $60. There is no way that we can finish. We only have remaining 60. 340, 400 minus 340, with the remaining 60, the project cannot be completed. So we need to redefine the budget here. All right. So from here, after day 25, now we recalculated the estimated cost at completion. So EAC, estimated cost at completion, which is based on how do we do it. So we earned 50%. So remaining 50% is still here. We have We spent 340 already, but are only 50%. So for the remaining 50%, we will need to increase the budget to 500. That again, there is a planning and estimation for the remaining set of tasks. There is no specific rule that we cannot apply a rule of thumb, as simple as that. So if it is 50% here, let's just double the number. So if we cannot simply double the number because there are many other factors involved. If you look at the initial plan value, this is not a linear curve. This is not a linear curve. So there are specific factors involved at each time step of the budget, with the work packages involved in those time. Right. So this is not a linear curve, but so by considering those factors again, we can now have the estimated cost at completion, which is the refined budget, at somewhere here below 500K. All right. So any questions, any confusion, please, you can ask. No questions so far? Okay. How can you select EAC? Okay, so as I said, same as BAC, right? So the way we did BAC, budgeted cost at completion, for the total period of time, we apply the same principle for the remaining period of time to complete EAC. Okay, so after day 25, if we have completed 50%, that by spending 340K, 50% complete at a cost of 340. So when 100% of 680, no, this is not the case. This is not the case because there are number of other factors for each work packages, how much time they need, how much budget they need for a specific item. So in a simple word, the way that we planned the budget initially to calculate the BAC, now that we have 50% completed, 50% of the work is completed at a cost of 340. Remaining 50% here, this is the remaining cost. You can see this curve is a little bit flattening. That means it's not rising in the first half, but the second half is a bit flattening curve. So we may be needing less amount. It's not a numerical double, but it depends on the factors involved in the time phases here. All right, those are again applied for the remaining period of the project to calculate the estimated cost at completion. It's a complicated task. It needs feedback from the project team, and again, there is no guarantee that the project will be completed at the estimated cost EAC. So after maybe 75% here, we will see another curve of EAC higher than 500K. So it can again increase. This is the remaining target. That's right. That's the appropriate word to say. This is the target for the remaining part of the project. I mean, set another target. So we cannot just let the project go off the control. We cannot just lose the control here. As soon as you see that only 50% is completed at a cost of 340, which is almost close to the planned budget, but only 50% of the completed, that means we need again another plan to still keep the project within our control as much as possible. So EAC serves the purpose of that. So again, because BAC failed, this one failed, we can't complete it. Now we need another BAC, which is to distinguish from the original BAC, we call it EAC, estimated cost at completion. This can fail again after 75%. We'll check the earned value, actual cost. We'll compare that to the PV baseline, and then if need be, we may need to recalculate the EAC again. Okay, I think that explains pretty much all the basics for earned value, schedule variance, cost variance, planned value baseline, and actual cost. Okay. All right. These are 6 steps to develop that integrated cost schedule system. Step 1, 2, 3 are done in the planning stage. As you can see, work breakdown structure. This is part of the planning stage. Then develop work and resource scheduling process. This is part of the planning stage, resource scheduling process. And then develop the PV baseline or planned value baseline, part of the planning stage. Right. 4, 5, and 6, these are sequentially calculated over the period of time during the execution of the project in the execution stage. So 4, 5, 6, these are the critical number or the critical terms that, that helps us in tracking the progress of the project. What is 4? 4 is actual cost. Collect the actual cost for the project for the work performed. Simply, receive all the invoices and check the numbers. What is the actual cost of the overall work that has been done so far? Earned value, multiply the % of work complete times the original budget. Now, when it comes to earned value, there can be 2 different levels of earned value. One is earned value at work package level. And the overall project level. All right. In the previous graph, this is the overall project. This is the earned value for overall project. If you look into project duration and actual cost, % complete, planned value, so this gives us a good indication of the overall project. If we look into, so this is the macro level scenario of earned value. If you look into micro level, we can also calculate earned value for work packages, and then later on add them up to get the total earned value of the entire project. Then number 6 is calculate the variances. What is the schedule variance and cost variance? This is SV and CV. So 6 steps for to develop an integrated cost schedule system. I repeat again, 1, 2, 3 done in the planning stage, and 4, 5, 6 is a sequential process. Is as the project proceeds, we look into the number, we calculate the actual cost, what is the percentage of work completed so far, multiply by the planned value number or original budget, we get the earned value. We do it in the work package level, and then we add them up to get the overall earned value of the project, and then we calculate the schedule variances, SV and CV. There is actually one more step which is not mentioned here. It is not part of the cost scheduling system, but this is more of some indexes. if you look, say for instance, the CPI index, what is this? If we look into the CPI index, we should have some understanding of the overall performance of the project. So there are a number of indexes that we can calculate once we have step 6 done. Once we have the SV and CV numbers, we can then calculate a number of indexes to have an idea of the overall progress and performance of the project. A simple flow chart that shows, that demonstrates the how work breakdown structure, then integrated to work packages. That work packages then goes to planning, scheduling to form the baseline budget, all right, which can help us in controlling the time cost specification by deliverables. So, a simple illustration that shows the interrelationship from the very beginning, the work packages or work breakdown structure, how that can help us in building the baseline budget or PV. Development of project baseline. How do we do it if so in the development process of the baseline, what what specific rules that we follow in constructing the budget baseline. So if you looking at the example here, there are, so what cost is included in the baseline? This is actually the direct cost related to labor, equipment, and materials. But I wanted to show you the actual process of what we really do in constructing the budget baseline. All right. I think I need to rearrange some of the slides here. All right. Okay, let's go back to so in the development of the budget baseline, associated to each work package, costs are placed exactly as they are expected to be earned in order to track them their original point. Percent complete, or how much, what percentage of the task is being completed. When we see the example here, I should be able to explain it more in detail by giving you some examples. The purpose of baseline or PV, you already know, that can help us in defining the limits for, in terms of with the time, the cost and time of any project, that how these are related as the time proceeds, how much budget we should spend. These are the information that we get from the PV or baseline budget. What are the variance analysis we can? So two types of variance. One is the cost, and another one is the schedule variance. Earned value with expected schedule value, and earned value with the actual cost. We already covered that. So SV and CV. So what we need to do in assessing the status of the report, we need the planned value, earned value, and actual cost to calculate the schedule variances. It make a simple statement. So if the variances are positive, situation is good, in favorable condition. If it is negative, this is an unwanted situation to be in. All right, so the definition of cost variance and schedule variance, if we take the mathematical terms, so cost variance is what? Earned value minus actual cost, right? And schedule variance SB is earned value minus the planned value. All right. Okay, next is, I already explained this graph. Next one is how the positive and negative, how do we know that whether the SV and CV is positive or negative? So if you look into CV for earned value minus actual cost, SV earned value minus planned value. So if earned value is less than PV, schedule variance should be negative. Also from actual cost, this is negative. All right, next is this one, schedule variance is positive, so earned value is more than schedule variance. So this is the planned value, this is earned value. All right, so now we can see that we have a favorable or positive schedule variance. So the project is going ahead of in terms of the schedule, but how much value we earned and how much value we plan to earn. Cost variance, again positive. So here earned value minus actual cost and earned value minus planned value. Both are positive. So there can be cases like one positive, one negative. Now it all depends on specific situation. So cost variance and schedule variance, two different variances that we calculate from earned value and the actual cost. Work breakdown structure with cost account. A very simple illustration with the total budget here. How they how do we break the total budget into specific work packages? How this is allocated? So in terms of the total number. So as I said, so we can calculate earned value in the work package level and then add them up to get the total earned value of the project. Baseline. Now these are some of the figures that shows us how we can calculate the planned value. So if we take into account, if we take an example of the digital camera prototype from the baseline Gantt chart, we know that there are number of activities from A, B, C, D, E, F. What is the duration of each activity? All right, starting from week 2, then week 2 to 6. These are the slack. Right, so we have the baseline Gantt chart for any specific project. Next is this one from the project network diagram. We have the schedule information. All right, and how can we interrelate that baseline budget? So for every work package, ACD or work packages, activity or work packages. Starting from A, these are what? Duration, early start, late finish, slack, total PV. Where it comes from, right? So here we know that the PV or planned value for design and specification is already defined in the work breakdown structure during the planning phase. So we now have the planned value for each of the activities within the project, right? We have a budget of 340 or 320. Budget of 320K. That budget is now subdivided in with 6 deliverables from design, shell, power and shell, memory software, Zoom system, assemble and testing, how this will be allocated. In total, that should add up to 320K, right? So for each of those work packages or activities, now we have a plan value. So for C, the plan value is in the planning stage. We already defined that C must be completed within 100K budget. For D, we allocated 35, 120, and 30K. Where does it come from? Again, I repeat, in the planning stage, this is the allocated budget for each work packages or activities for the entire project. All right, so if we further break it down, if we break it down further in terms of the time period, we should be able to form the budgeted, the baseline budget need. So if we have allocated 20K, the duration for finishing or completing activity A is from 0 to 2 weeks. And the budget is 20K. So expectation will be every week we should aim for completing 50% of the task at a cost of 10K. Right. Activity B, starting from week 2, we have a budget of 15K, right? Now, it depends on the people who are involved in activity B. So they can come up with, depending on the nature of activity, we can define, all right, from week 2 to 3, the amount of work that we have on the table should be done by 5K, and the remaining 10K should be reserved for the second week. It goes like that. You can see there is no specific trend. It's not like for activity A, this is a simple 10 and 10. I mean, we divided 50-50, but for say, for example, for C, 20, 30, 30, 20. So there is no specific set of rules. These are activity dependent. These are activity dependent, depending on the nature and type of work that is involved in that work packages. Why do we do it? We need to do it because we need a detailed budget for a PV by period. So for every week, what is the PV, planned value, right? At the end of week 1, we only have, from the early start, we can see only 10K. End of week 2, again 10K. So 5, 25, 15, 40, 50, 40, 20, right? Goes like that. Cumulative PV, simply add it up. So add the numbers, it should go to the final amount of the budget. So that's how we formed the project baseline budget, or the planned value PV during the planning stage. So it's not necessary that the project will exactly follow the PV curve. There will be more or less, but as long as we can keep track of the amount spent and the total budget, that should be good enough. Next is, all right, so now that we have PV, then how do we proceed to the next stage? Now, once the project started, you can see the time period. Starting from 0, we have up to 11 time period. All right, 11 time period and the total budget of 320K. So for each, at the end of each time period, we look into the PV, EV, and the variances and prepare a table. This is a continuous process. For after every time period, you must complete that table, and by looking into the numbers, form the table. That should be the a very critical information for the progress report. So we need, that means in this specific project, we need 11 progress report at the end of each time period. Now, in the status, so what happens if, So say for example, after end of period 1, which ones we report? There can be 3 different scenarios. First one is an activity hasn't started at all. So after end of week 1, right? So B, C, D, E, F. These are the activities not started yet. These are simple. So the earned value for those activities will be 0. At the end of, say for example, end of period 2. End of period 2, we can see that some activities are completed, just started, but without any completion, right? End of activity 3, some are completed, some are partially completed, right? So when it comes to, so there will be 3 different scenarios. Either the activity started, or activity completed, or activity partially completed. Now, when it comes to percent complete, that will help us in defining the earned value. In the status report, look into 1, 2, and 3, not finished or in progress. If it is not started yet, earned value will be 0, simple. If it is finished, completed 100%, then we can multiply 100% with the planned value, PV, to calculate earned value. If it is in progress, so that means what percentage of work is being completed by end of that time period, multiplied by PV, we get EV. Okay, now let's go to one by one. After end of time period 1, what it looks like. So in the example that we are analyzing here, end of status report, end of period 1, only task A started. All right, B, C, D, F hasn't started yet. Only task A started, and the end of period 1, 50% completed. All right. So if we know that 50% is completed, simple, we can now calculate earned value. What is the earned value? If you go back to this table, A was scheduled for, the planned value for A was 20K. At the end of period 1, 50% completed. So 50% times 20, earned value is 10. What is the actual cost? 10K. Actual cost, this is not a calculation, this is a feedback from the project team. After end of check all the invoices, all the expenditure, add the numbers, and you get the actual cost. So actual cost, these are the numbers that you get from the project team. All right, plan value, this is from the planning stage, from the table PV, we plan that after end of week 1, we'll be spending 10K. All right, cost variance is the difference between earned value minus what? Actual cost. This is 0. This is earned value minus planned value is the schedule variance. This is 0, right? So end of period 1, finish. End of period 2, now let's move on to end of period 2. From the status report, we can see that now A is finished, 100% complete. B, C, D, E, F, not started yet, right? And when A is finished, when you got all the cost account, we add it up, we can see that the actual cost of finishing A is 30,000, right? So what is the earned value of A? If it is 100% complete, 100% times PV of A. Does it make sense? PV of A, we go to the table here. This is A, and PV of A is 20K multiply 100% of PV of A 20, so earned value is 20K. We earned the value, 20K value of work at the end of period 2 by completing by 100% completion of task A. This is what it means. Then actual cost we get from the project team actually, all right, so we achieved, the earned value is now 20K. We achieved the value of 20K worth of work. What is the actual cost? Actual cost 30K. Planned value, again, go back to the table, 20. Cost variance, earned value minus actual cost, this is minus 10K. Okay, schedule variance, earned value minus planned value, this is 0. So planned value was at the end of period 2, the planning was to achieve 20K worth of work, and we earned the same. So in terms of the schedule, if you look at the schedule variance, that means at the end of period 2, schedule variance is 0. So there is no variance. The project looks like, well, whatever the plan was initially by end of period 2, the project looks like it is exactly on the same schedule. So schedule variance is 0. Can you explain AC again here for this case? So AC is actual cost AC for actual cost. This is the amount. This is the dollar value we get from the team. So the dollar value given by the team to complete the task. So say for instance, I gave you your team of 3 and your task is to complete, your job is to complete task A. When you finished it, you came back to me, sir, we finished task A, but we spent $30,000. This is AC, actual cost. Is it clear? Okay. All right. End of period 3. Now, next one, end of period 3. Now that we know A is finished, 100% done. This is already calculated in end of period 2, so we can simply copy and paste at end of period 3 what is done for A. B, C, D. Right? B 33%, 20%, and 60% complete. So what is the earned value of B? With 33% complete times PV. PV was 1,535. Okay, 1,535 PV for B, C, D. So 33% times 15, this is 5. 20% times 100 times 35. This is 21. Okay, actual cost, this is the dollar value given by the team to complete that actual cost. So to complete 33% of task B, we got invoice of 10K, 30K, and 20K respectively for each of those activities. All right. Once we have these two, significant part of the status reporting is done. PV is already, we have the number of PV from the planning stage, right? And these two are simple, you know, subtraction from EV with actual cost and EV with the planned value. Now look at here, as we proceed, this is -10, this is 5 minus 10, so this is -5, 20 minus 30, -10, 21 minus 20, so this is +1. So this is overall earned value, actual cost, planned value, cost variance, and schedule variance. The schedule variance looks like this is ahead of the project, right? Schedule variance is an indication of the timeline of the project with the dollar spent. Cost variance looks like this is flowing. By end of period 3, we can see that significant variance already, -24 from what was initially planned. Alrighty. So by end of period 3, we have the total number. The process goes on and on. End of period 4, 5, 6, and 7. The same process, reiterated again. All right. So the results, so at the end of period 7, we can see that the project is over budgets by $70,000, which is by end of period 7, we have a cost variance of -70, so $70,000, and a schedule variance of -40. So the schedule variance was positive by end of week 3. This is negative, this is positive, but as we are proceeding to 5, all right, end of period 5, this is the worst hit. Now we have the hardest hit here, -77, -27. Okay, that is again came back a little bit. So it's like a share market of after every time period, depending on the progress of that specific task schedule for that period, how it is progressing, performing overall. That is what contributing to the cost variance and schedule variance. End of period 7, we can see the total earned value, actual cost, and PV, and the variances. If you plot it in a graph, right, end of period 7, this is the planned value. Simple, put the numbers and connect to plot the graph. Same goes for earned and actual cost. So here we can see we need to recalculate the budget for what? To calculate EAC, estimated cost at completion. All right, so that's how we construct the schedule cost for a project. Now, any questions, or if you want me to repeat any part of these, please, you can ask the question. Look at the slides. Make sure that you understand the process. EAC, estimated cost at completion. So that means again, EAC is again the way we calculated PV. Here we need to go back to that process again. So at the end of period 7, what is completed, what is remaining, all right? So at the end of period 7, what? We can see that A is finished, B finished, D finished, C 90%, E and F 0%, right? So C 90% complete, E and F 0%. So EAC, estimated cost at completion. Now E and F, these two are what? We have the planned value of 120, 30. So we cannot suppress that. So we need to add that E and F plus 90% of C is done. So it's still 10% remaining of C. So we need to budget for the remaining 10%. Okay, so we reschedule again for the remaining set of tasks after end of period 7, which is here, end of period 7. Okay, so that means if we look at here, so let's now forget these numbers. Starting from end of period 7, we have D completed. So D is it done? End of period 7. D finished. Okay, so D finished, C 90%, E and F 0. So then again, go back to the table here. E and F, we need these, right? For F, this is E. I'm sorry. So this is E. So E hasn't started yet, and end of period 7. So we need to move that. So that 120 and 30 should be here. Plus 90% is done. So that means at least if we budget for 10K, for the remaining 10%, or depending on the nature, it can be 10K, it can be 20K, right? We add this up and we recalculate, so which is 120, 150, 170. So from here, at the end of period 7, actual cost is 230, plus we still have 170 left, which is 400. Initial budget was 320, right? So it looks like now it will be hitting the estimated EAC for the remaining period of for period 8, 9, and 10. It looks like it will be hitting 100, close to 400. If we allocate 10K, it will be 160. All right. So that's how we calculate EAC for the remaining period of time. Any other questions? No questions? Okay. All right, so now let's proceed. So now that we have up to end of period 7, so we should be able to form the cost scheduling graph for up to end of period 7 with PV, AC, AV, and the cost and schedule variances. Whether it's tracking the BAC and what is the new EAC for the remaining period of time. Looks like the project is over time. So by week 11, we won't be able to finish it. We should extend the time. Next is what? Okay, so after end of period 7, this is the tracking Gantt chart, how it looks like. I mean, for each set of activity, which one is finished, which one is not finished, what percentage is finished, what needs to be pushed. So here we can see E hasn't started, so E should be pushed to week 8. All right, so it helps in proper planning after every time period of the project. Project roll up after end of period 7, whatever we plotted in the graph and in the table, this is a summary of the total scenario. A summary of whatever we calculated after end of each time period. All right, now this is what the a summary related to the work packages or the sub deliverables for the project. After end of period 7, if we put it in tabular form, we can see that there is a cost variance of -70 and schedule variance of -40. Here, after end of each time period, what it looks like, slowly getting to the worse and worse and worse after each time. So why do we do it? We do it because we need to identify, we need to know who are the culprits, who are performing not to the expectation, or where the budget is blowing up, where the project is running behind the schedule, who are the team of people involved. So we can know design and specification, they are performing pretty well with schedule variance 0, cost variance -10. Power and shell team, they are also progressing well with cost variance of -5. Memory and software team, all right, so you are the culprit here. So you are destroying the, you are making the project, you are the one who is contributing to the scope creep, or, blowing the budget and schedule with -10 and -30. Again, the Zoom system team, they are overspending with -25. So we need to know that what teams and what level it is behind the schedule or above the budget. Okay, next is indexes to monitor the progress. Indexes to monitor the progress. These are some simple index. CPI is the most commonly used, very important and most commonly used index in this process. CPI, a ratio of EV by AC. Okay, what is CV? CV for cost variance, EV minus AC. What is CPI? EV divided by AC. So how efficient, what is the cost efficiency of work accomplished to date? What is actual cost divided by earned value? So how much money you actually spend and how much value we earned by spending that money. So this is the index of CPI. A very simple one, but a lot of information on the overall performance of the project. Then we have an SPI. The good thing to remember is schedule variance as V for EV minus PV, and schedule performance index SPI EV divided by PV. It measures the scheduling efficiency to date, the planned value to date so far, and what is the earned value. So earned value divided by planned value gives us the scheduling performance index SPI. Some examples given here, please read to so that you can have a better sense of what these indexes means. SPI of 0.8. So after the end of period, what is period 6 or 7, whatever it is, if we divide EV by PV, we can have a schedule performance index SPI of 0.8. So In simple word, we are getting $0.8 worth of work has been accomplished for each $1 schedule of work. So for each $1 actual, schedule of work, only $0.8 is being completed. So that's a schedule performance index. So the project is behind the schedule. If it is less than 1, behind the schedule, as I said, so less than 1 behind the schedule, greater than 1 ahead of the schedule, exactly equal to 1 on schedule. As for the CPI, if it is less than 1, over cost, 0 on cost, greater than 1 under cost, right? So these two indexes, if as a project manager, don't look at all the detailed table, WBS, OBS, PV, all those budget numbers. Simply ask, what is the CPI? 1.2, 1.1. What is the SPI? So this is the number that you can ask on the run, on the go, anytime. Pick up the phone. What is the SPI after the end of period, after the schedule period 3? SPI 1.3. All right. So the project is ahead of the schedule. What is CPI? 0.7. So that's below 1. So the project will be over cost. That means we need to plan immediately to maintain, to control the budget for that project. Okay, next is some more example of CPI. Please have a look what the numbers mean. If you have a less or more than 1 CPI value. And CPI is the most accepted and used index in monitoring the project progress. We can also plot graphs to check the overall progress and performance of any project. End of each reporting period, look at the CPI and SPI, how the project is progressing. We can see that SPI end of period 3, 1.1. So this is the time we had a very good time, and then again SPI dropped below 1. Finally, somewhere here SPI 0.8. Same goes for CPI from the beginning. CPI was below 1. Now after end of each reporting period, it came back a little bit and then again dropping down. So how CPI, how the overall budget and the schedule is performing for the project, that can be we can also have the graph plotted for after each time period. What is PCIB? PCIB is percent complete index budgeted cost. PCIB, percent complete index budgeted cost. I repeat again. This is what earned value divided by BAC. After every time period, what is the earned value? And we already have the BAC from the beginning of the project. If we divide it, that is the percent complete index budgeted cost, PCIB. If you compare that with actual cost, we have another index, which is PCIC for percent complete index actual cost, AC divided by EAC. Some more indexes, management reserve index. This is what? This is for every project, the top management has a specific reserve, some additional fund. If something goes wrong, there is a management reserve that we can use. What is the management reserve for that for after the end of each time period? So the total amount of management reserve that has been absorbed by the cost overrun. Obviously, when the cost overruns or when the budget blows out, where is the additional money coming from? It comes from the management reserve. If they reserve some additional pool of money that is being used to cover up that additional cost after each time step. Mostly in civil construction, this has to be, there should be some management reserve to cover up the cost of the additional cost in any specific work schedule. So what is management reserve is CV divided by MR. I think we have an example here. CV for cost variance, MR for management reserve. So how much cost, what is the cost variance up to date, and how much is the management reserve? So what percentage of management reserve is being consumed by the cost variances? That's what it means. So some examples of PCIB, please have a look, and PCIC, so that you understand it better. Please have a look. Management reserve, CV by MR. CV is cost variance after each time period. And say, for example, the management reserve was only 40. So this is already 350% over the management reserve. So management reserve is not able to fund that additional cost. Already, it's significantly beyond the level of management reserve, right? Then what's next? How much time you have? Okay. Next is some additional rules applied for the short duration activities or small cost activities. 0%, 100% rule. So assume that 100% of the budget credit is earned at once and only when the work is completed. Another one is 50-50 rule. So it allows 50% of the value of work package budget to be earned, started, and 50% when the work is completed. So additional earned value rules. So these are some additional rules in calculating the earned value. A rough estimate. So if we do not have, if we don't want to follow that percent complete rule, right? For every work packages, what we did was what percentage of the work package is completed multiplied by the planned value PV that gave us the earned value. Right. We have two additional rules here. Rule number one, it assumes that we can only allocate 100% budget credit to the earn once the work is completed. So it's either 0 or 100. So earned value is, if we apply this rule, so earned value for task C, which is 90% complete, it will still be 0. If we apply the 0-100% rule. Unless it is 100% complete, we cannot allocate we cannot calculate the earned value. 50-50 rule, this is, this allows 50% of the value package to be earned when 50% is completed. So as you can see there, I mean, if it is 0-100%, there can be significant, I mean, unless we have 100% completion, we do not know, we cannot have the actual number. So these are not precise. The percent complete rule is obviously the best option, but in specific cases, you can also see that the 0%, 100% rule is applied, or 50-50 rule is also applied. So if you don't understand, if you see that an activity is 90% complete, but it's still earned value 0, you may question like, what's going on, because you have 90%, but then you need to understand this is a different rule that was applied in calculating the earned value for that specific part. So those are 0-100% and 50-50%. Remember that these two rules exist. Percent complete with weighted monitoring gates. What is this? What is up? Let me see if I have some examples here. No. So what percent of the project is completed? So usually there is, how do you precisely calculate what percent of work is being done? So there are usually some monitoring gates. as we go in terms of the timeline, or divide the set of activities. Like if I have to budget this and develop this software programming and then build this hardware with specific milestone, those are monitoring gates. As you complete, so you can you can allocate a specific point. If we have completed up to the programming stage, maybe 25% of this work package we can assume to be completed. So that is an estimation. Again, this has to be realistic number. So you cannot claim for a work package. You cannot just put arbitrary number just to look it better. So you cannot claim that 75% of the completed, whereas only 20% of the work is achieved, 80% is still remaining. So you cannot put a good number just to, an unrealistic number just to make it look good, but it has to be something related to the work packages, how much percentage is complete with monitoring gate. That means you are closely monitoring the progress of the work package. If we finish, if we pass this gate, this percentage of work is being completed. That's how we calculate the percent rule. Okay, next is forecasting the final project cost. So EAC. Now here is the method to use to revise estimate. So what happens now that we know up to here, we know that PV from PV actual cost, earned value, then schedule variance and cost variance. Once the SV and CV are negative, cost variance and schedule variance. If these are negative, so we should be looking immediately. We should refine the budget. So estimated cost at completion. Then again, as I said, so this is again in the same process that we calculated PV. So it then we check the remaining amount of task. What is the budget involved? All right, we obviously seek some expert feedback into that process. That original base and cost, and calculate the new EAC estimated cost at completion. Forecasting cost at completion, which is EACF, uses actual cost to date plus an efficiency index up to that specific time period. What is efficiency of the team or the overall project, to forecast the final cost of the project. We have an example of EAC and EF. Let me see. Yes, so to calculate the EAC revised and EAC forecasting, we have specific formulas. EAC revised and EAC forecast. We use specific formulas, AC plus ETC. So AC for accumulated actual cost. ETC is revised estimated cost to complete the remaining work, which is where we look into like E and F is still remaining, and 90% of C is done, 10% is remaining. So we look into those numbers. This is ETC revised. Okay, if it is EAC forecasting, this is ETC plus AC. So ETC is work remaining divided by CPI, work remaining budgeted cost minus EV, and CPI you already know. So here is an example given to, if you can, both are, so equation 1, this is equation 2. Both are related to what? Estimated cost at completion. I mean, what is the future cost look like? How the budget will change? These two numbers will give us the information. One is estimated cost revised. This is simple. And in the forecasting, the formula that we use, it takes into account the CPI or cost performance index. So this is ETC revised. Simple, you can see the difference between these two. ETC revised is the cost to complete the remaining work. We simply look into the remaining work, no performance involved. Whatever is done is done. So up to period 7, whatever is done is done. The remaining period is, we now have ENF 100% remaining and 10% of C remaining. And what is the amount involved in to complete the remaining part? This is revised, right? In calculating EAC revised, there is no performance index or nothing involved here. But when it comes to ETC forecast, that can be a bit different than the revised, in a sense that now we need to check the CPI number or cost performance index, CPI. So CPI is involved here because we need to look into CPI because the same project team will be continuing to work for the rest of the project. So what is the overall performance of the team in up to the end of period 7, which we can gain from CPI. So work remaining divided by CPI, that helps us in calculating EACF. So EACF, estimated cost is forecasting estimated cost at completion, ETC plus AAC. AC is what? AC is actual cost of work completed to date. ETC, estimated cost of work, remaining work. Now in calculating ETC, this is the remaining work divided by CPI. Remaining work, budgeted actual cost minus earned value. Look here, we are subtracting the earned value. Simple. So from budgeted cost minus earned value, right? This is the amount of work remaining. Then divided by the CPI. So that should give us the estimated forecasting estimated cost, EACF. That should clearly answer a lot of your question of how do we actually calculate EAC after the end of any specific period. Please raise any questions if you have. I'm happy to explain it. In the next slide, there's an example given. So if you look at the example, it'll be more clear. Look at the example and let me know if there is any confusion. Okay. Any questions, please? Yes, Yasin.
Sir, it's not related to the class, but I want to ask a question. Is it okay?
Then please wait until I finish the lecture.
Yeah, thank you, sir.
All right, next is so some more index related to I think some examples here. We have another index known as complete performance index to complete two complete performance index. So TCPI, how do we calculate TCPI? Look at the equation here. BAC minus EV, so earned value, and minus actual value to complete, that means for the remaining amount of work that yet needs to be completed, what will be the performance index for the remaining part of the work based on the factor that now we have the earned value and actual cost. And if you compare that with the budgeted actual cost, how does the index look like to complete the remaining amount of work? So if that means what? If it is less than 1, the ratio less than 1 indicates what? If it is less than 1, obviously this is higher, right? BAC minus AC, this is lower. Or the other way. If it is less than 1, obviously this is higher, right? And this is the lower number. If this is lower number, that means earned value is what? Earned value is more. This is actual cost. Actual cost is actually less because both are subtracting, right? Actual cost is actually less. So a ratio of less than 1 indicates an ability to complete the project without using all of the remaining budget. So this is the only index. So if TCPI is less than 1, that's actually a good indication. It's actually a good sign that the project may not need all of the remaining amount of budget to complete the remaining amount of work, TCPI. In the next slide, this is a typical example or case study. I'm not going to go in detail. Other control issues, issues in maintaining the control of the project, technical scope creep. Then you have baseline changes, data acquisition cost and problems. The new baseline, that means depending on the overall performance after each time period, what is the new baseline look like? All right. To accommodate that, the scope of the project needs to be changed in terms of the schedule and budget. This is a simple example, but of the communication plan class exercise. Number of class exercises. Do you want me to go through these exercises or explain any part of it? Let me know. Do you want me to explain? Anyone? This is 1 and this is 2. 2 class exercises. One is very simple. After day 51, a project has earned value of 600, actual cost of 650, a planned cost of 560. What is SB, CV, CPI? Simple subtraction and division. Yeah. Exercise 1, nothing to explain. I mean, all the numbers are given, simple subtraction, and then for CPI, EV divided by AC. You can ask me in the next class or in between. You don't need to wait for 1 week. You can always email me if there is any confusion. We can set up a personal Zoom meeting. If any one of you need personal discussion, please email me. I can set a one-on-one Zoom meeting with you and go through all this slide again. Next is the next example. This is exactly the similar one that I've discussed in the lecture slide that shows the task plan value, all right, with the project baseline budget, total PV, cumulative numbers. Then after the end of each period, develop the EV, AC, PV, SV, and the CV table at the end of each period. Fill out these number. End of period 4, period 8, what is these numbers look like? This is the solution. If you don't understand any number, any part of these, obviously I'm happy to explain again. All right, so I think there is, so this is 1. So let me just give specific numbers here. So this is class exercise 1. This is 2. And this is 3. Similar example. Fill out the table. Okay. So that is all for today's lecture. Now I will open for question and answer.